Introducing the Blinky-Lite Architecture. From isolated container networks, to publish-subscribe device communication, to role-based authentication via JSON Web Tokens, to virtual private network communication through a reverse proxy server, Blinky-Lite provides an organized, layered approach to remote access security. Security was a driving force in developing Blinky-Lite. However, to really understand Blinky-Lite, I need to spend a few minutes describing the Blinky-Lite architecture. The Blinky-Lite architecture is based on Linux containers. A Linux container is a set of one or more processes that are isolated from the rest of the system. All the files necessary to run them are provided from a distinct image, meaning Linux containers are portable and consistent. Because of their popularity and ease of use, Linux containers makes Blinky-Lite very extendable. Containers are also an important part of IT security. For example, all the Linux containers in Blinky-Lite communicate on an isolated container network. Blinky-Lite Linux containers are managed by Portainer, which itself is a Linux container with an easy-to-use web interface. The core containers of Blinky-Lite are the application server, the database for storing data and application configuration, and the notification server for alarm handling. To communicate with internal devices, Blinky-Lite uses an MQTT container. MQTT is a publish-subscribe communication protocol developed by IBM for the monitoring of oil pipelines running through the desert, but is now a very popular IoT communication protocol. A key security feature of MQTT is that every device initiates authentication to the communication broker, and the publish-subscribe topics for each device is linked to a unique device authentication. This is much different than most other control system protocols in which communication to the device is initiated externally, which can compromise security. Also, in traditional systems, devices can be overwhelmed by too many requests for data. However, MQTT provides inherent data pooling. That is, devices only publish data when they are ready, regardless of how many requests from users. As discussed earlier, with Blinky-Lite, the user can only interact with the control system through applications served from the application server. The user accesses the web applications through a reverse proxy server that is configured to permit only appropriate routing requests from the user. Next in the line of defense is role-based authentication. In the Blinky-Lite database, we can assign roles or permissions for each user. These roles limit which applications a user can use, what the user can do in each application, such as read or write, and what data types and data the user can interact with. When the user logs into the control system with two-factor authentication, her credentials are matched against those stored in the user database. Her roles that are defined in the user database are encrypted in a JSON Web Token. This token is then sent back to the user and is stored as an encrypted cookie in her browser. Each time she interacts with the application server, she presents the encrypted token, and the server decides whether the request can be granted, based on her allowed roles. At this point, Blinky-Lite is perfectly suited for operations inside an internet firewall. However, a remote access control platform is not of much use if you cannot securely access it from outside your facility. For secure remote access, Blinky-Lite provides a tunnel container that sends traffic through the firewall, using a virtual private network. Now, Blinky-Lite goes one step further by routing the VPN to an outbound-only, reverse proxy server, located in the cloud, such as Cloudflare Zero Trust. This reverse proxy server permits only allowed routes to the application server, and provides the first line of defense against the wild world of the Internet, such as denial of service attacks. Now we have the configuration for a single Blinky-Lite control system. But, because Blinky-Lite uses MQTT as its device communication protocol, Blinky-Lite can be easily extended to a multi-node distributed control platform, by bridging multiple Blinky-Lite systems to an external MQTT broker. By configuring the topics on the external broker, it is possible to share only a certain subset of devices between Blinky-Lite systems. This configuration provides an excellent balance between data sharing and compartmentalizing. Note, again, that connections to the external broker are initiated from the internal brokers, providing a secure connection. That wraps up our quick overview of the Blinky-Lite architecture. From isolated container networks, to publish-subscribe device communication, to role-based authentication via JSON Web Tokens, to virtual private network communication through a reverse proxy server, Blinky-Lite provides an organized, layered approach to remote access security. Check out how to install Blinky-Lite at the blinky-lite.org webpage.